Hello everybody. I thought that it's time that we have another video, and this time we're going to have to do a little classroom lesson because that is really the only way to present the information which you need to be aware of to debunk climate science. And yes, climate science as a whole, in particular climate alarmism, you can debunk with basic knowledge in thermodynamics. So we're going to have a little class today called Thermodynamics 101. And the title of this class will be Socrates Debunks Climate Science. Climate alarmism, obviously, and most of the field of climate science. So here's a quote that I have had on my computer for about 20 years through a series of 4 or 5. How many computers have I owned in that time? A lot. I would only ask you to be consistent, or if you must change, change openly and let there be no deception. So we will see that this will be a relevant quote for this lesson today. So Thermodynamics 101. Here's a very, very important quote from Schrader in his textbook on thermodynamics called Thermal Physics. I think this edition is the 2001 edition, and this is from page 17, so very near the beginning. Much of thermodynamics deals with three closely related concepts: temperature, energy, and heat. Much of students' difficulty with thermodynamics comes from confusing these three concepts with each other. Not only is it students, it is also climate science's difficulty and climate alarm's difficulty with these concepts. Although in the latter case, students are innocent. In the latter case, they darn well know that they're lying about thermodynamics, as I will demonstrate here in a moment. So temperature, energy, and heat. So the first law of thermodynamics. The first law puts together these three basic fundamental concepts of thermodynamics into a single encompassing definition. This equation is the first law of thermodynamics. That's what the first law of thermodynamics is. We must understand, classroom, I want you to understand and appreciate that in physics, physics is math. Physics is not words. We use words to communicate ideas, yes, obviously, but in physics, laws are math. They are mathematics. They are mathematical relations or definitions or tautologies which have been arrived at and deduced and solved after many, many years. In the case of thermodynamics, hundreds of years, possibly even thousands of years if you want to take that far, of experimentation and tinkering and figuring out the math and all that sort of good stuff, which is real proper science, not what we have today in modern academia, which is just, basically daycare for grown-ups. We have, traditionally real science being done, real mathematics being done. So in physics, real physics, the definitions are mathematical. The laws of physics are mathematical. They are not words that you can change on a whim or just make up new word definitions because they sound logical. This is important because words fall foul of Gödel's incompleteness theorem. Words can contradict themselves, and you can say things in words, you can make statements in words which have no meaning whatsoever, such as, this sentence is a lie. Mathematics gets around Gödel's incompleteness theorem because mathematics is tautology. Gödel's incompleteness theorem applies to systems of axioms. Mathematics is not a system of axioms, it is tautology. Therefore, Gödel's incompleteness theorems do not apply to mathematics because mathematics is based on 1 equals 1 or 1 plus 1 equals 2, which is simply the expression 1 plus 1 equals 1 plus 1. Okay, so for a thermodynamics classroom, we are getting off the subject and into a lot of philosophy, but you have to understand these things. You have to appreciate these things in order to be able to communicate rationally and sensibly in physics. And of course, this is precisely what climate science attempts to avoid. So, the first law puts together those three basic fundamental concepts of thermodynamics into a single encompassing definition. Here it is in math. Here are the terms. I'll read it. du equals q plus w equals m cp dt. So, what is this? So, du is change in energy. U is just used for the internal thermal energy of an object. So, this relates to a body, an object. And that is equal to, so the change in the internal energy of an object, of a body, is equal to Q plus W. Q plus W are heat, or work at the molecular scale, spontaneous work performed at the molecular scale, which I discussed in a previous video on what is heat. I talked about how heat is actually just work performed. And we have dT, which is change in temperature. So we have energy, or a change in energy, is related to heat, is related to temperature. So we have an expression which relates all these three concepts, which are related but not the same thing, as from the previous slide. Okay, so that's what the first law of thermodynamics does to us. It combines these three things, temperature, energy, and heat, which are confusing and people have difficulty with distinguishing, and they have problems with confusing these concepts with each other, but they're actually separate, and this equation describes them. Okay, so energy, so it's actually a change in energy, not energy itself, but specifically a change in energy, which is related to heat, and that is related to a change in temperature. All right, and this m would be the mass of the body in question, to which the change in internal thermal energy corresponds to, and Cp, that's the expression, that's just the constant term for the material substance's thermal capacity. All right, and the thermal capacity is basically just an expression for how efficiently an object can store free internal thermal energy. Okay, now as an aside, this is a really fun classroom, hey? Lots of asides. But this one is really interesting. As an aside, a very, very important and fascinating aside, this equation does not apply to space. Thermodynamics applies to material bodies, okay? Space is not a material body. Space is the opposite of a material body, obviously. Space is what contains material bodies. I'm a material body composed of many atoms, and this table that my laptop is resting on is a material body, and it has a temperature because the atoms and molecules in this table are vibrating at a certain rate, and they hold a certain amount of thermal energy and entropy, which defines their temperature. Yes? All right. So space, being not a body, has no mass. Space, being not a body, has no thermal capacity. Space, being not a body, cannot attain a temperature. Only material bodies at temperature can attain a temperature, can hold a temperature. Space, being not a material body, can therefore not hold a temperature. So we then also have to recognize by extension that space is not something which can receive heat. Certainly, objects like the sun can emit energy through space and into space, and this energy travels from the sun to the earth, for example. But at no point is space actually absorbing any heat, any of that energy. Obviously, that energy gets here unabsorbed by the space in between us. Space is not absorbing any of that energy. If it was, then it would be dimmed by the time it got here, because space would have taken some of it away, would have absorbed it, right? So space is not absorbing any energy, therefore space is receiving no heat. So space receives no heat. It simply transmits the energy through. Yes? Okay, so interesting. Interesting aside about space. Space has no temperature. Space is not a material body. Okay, so this expression relates these three concepts: energy, heat, and temperature. Perfect. Now, what is this good for? It's good for a lot of things. It's good for our whole world, everything that we have. So that's the equation. So the first law of thermodynamics tells us how to increase the temperature of a body. That's the most basic thing that it's good for. The first law of thermodynamics tells us how to increase the temperature of a body. To get a positive dT, so D means change, it's the symbol for delta temperature. So positive change in temperature, so that means an increase in temperature, where the context is heat and radiation and not work. And so, of course, this is relevant to the radiative greenhouse effect and climate science's idea of a greenhouse effect, where greenhouse gases are making the surface and the earth even hotter. So the context of that is heat and radiation, okay? So one requires positive heat, Q. So what is Q? So in order to get a positive dT, you need a positive Q to give the positive du, positive dT. All right, that's fine. So what is Q? The definition for Q, and of course this is again from thermodynamics textbooks, for conductive transfer, so that's when you have touching transfer, like a transfer of heat by two bodies in contact across a cross-section, this would be the expression. So Q, heat, is equal to a proportionality constant times the difference between the hot body's temperature and the cool body's temperature. Okay? And the expression for plane parallel geometry for radiant heat transfer, okay, is another proportionality constant. In this case, it's called sigma, times the temperature of the hot body to the fourth power minus the temperature of the cool body to the fourth power. So that's how it works in radiation. However, you can see that both for conduction and radiation, the heat transfer is the difference between the hot body's energy and the cool body's energy. Yes? So heat is what is required to increase temperature. And heat is a difference of energy, whether in a material or radiative scenarios. Okay? So each of the two terms of these heat equations are energy, and it is the difference between energy, which is heat. So heat is the excess energy, basically, of the hot body relative to the cool body. Yes? So for example, let's say that temperature hot represents the temperature of your hand, okay? And temperature cool is the temperature of an ice cube. When you put that ice cube in your hand has a higher temperature than the ice cube, and so the heat travels is positive then in that case, because this being bigger than this makes a positive value when you're subtracting cool from hot, obviously, right? Basic things here. So the heat is positive. That means heat is going from your hand to the ice cube, and you warm the ice cube, obviously. Right now, is T cool sending heat to your hand? Is your hand warming up? No, it's not. It's smaller. This is the equation for heat. There is no heat being sent from the ice cube to your hand. Your hand is in fact decreasing in temperature as it sends its heat into the ice cube. Yes? And so the same thing would be for radiation. If instead of holding the ice cube, you simply put your hand like this, really close to the ice cube, still you would melt the ice cube with the thermal radiation from hand. It would be a lot slower, but you would still do it. And the ice cube obviously would not be heating your hand. Right? We've all put our hand, you can put your hand up to your freezer, etc. Right? Stupidly simple ideas here, but God, I got to explain them now because of climate science. Okay, that's fine. I'll do it. I'm sure there's people who can appreciate this. All right, you guys. Thank you. Okay, so what to do when you don't like it. So if the definition of terms, so we've just been through the definition of heat, what it's good for, what the first law of thermodynamics is good for, how to increase the temperature of a body. Oh, you need heat. Okay. So what do you do when you don't like those definitions? If the definition of the terms, and these are the definitions from the textbooks from thermodynamic theory, do not allow you to say what you want to say, then what do? What would a person do in that situation? I mean, an honest and forthright person doing actual science would say, well, these are the definitions. This has been what's established. These things are true by experiment. I can verify them by myself. This isn't controversial. And so let's go with that and develop things based on there. But what if you have a theory like climate science, which wants to violate those definitions and say that the cold atmosphere makes the warmer surface even warmer somehow? Well, of course, you have to change the definitions. And this is what I just went through over the last week with a group of skeptics and two fake skeptics, or snakes in the grass, I call them, fifth column people, or people who are alarmists, supporting an alarmist cause but pretending to be skeptics, got in on the thread somehow. And so this is what they said. After I went through, in email, describing this previous slide, what the first law of thermodynamics is and what heat is and how it tells us how to increase temperature. And this is how it basically works. And so you can't say that a cold atmosphere can heat a warmer surface because those are the definitions. So what do? You change the definitions. So this is what they said finally at the end when I showed them, or when I explained these equations to them, which kind of exposes that they damn well know that they're lying. Because if the definitions from textbooks don't suit you, and they're not able to use the thermal definitions, the definitions in thermodynamics from textbooks to make their argument for the radiative greenhouse effect, then what do? I mean, obviously they have to change the definitions then, right? So it just goes to show. So anyway, this is what they says. They say, They said to me finally, your definition of heat is much too restrictive. Well, okay, so first of all, it's not my definition of heat. It's the definition of heat from thermodynamics and standard thermodynamics textbooks, and you do not find any other definitions of heat anywhere. Okay, so it's not my definition of heat, first of all. So I like how they're trying to say that. So your definition of heat is much too restrictive. We define heat as thermal radiation, which can come from an ice cube, and that this must be absorbed by any other body. And therefore, indeed, a cold substance can make a hotter object increase in temperature via radiation, because this is about energy, not your restrictive definition of heat, to which radiation doesn't apply. So you can see that this is just an insane statement where they've just made up a whole new definitions of things that allow them to do whatever they want. So now, in their new definition of things, because mine, which aren't mine, where it's restrictive, they just make up a new definition and they say, oh no, we're going to say that radiation from an ice cube does make you hot, does increase your temperature. And so it's like, okay, well, let's see your equations for that. Well, they have no equations for that. So in this case, it is actually a personal redefinition of terms. They're coming up with a new definition, which is the opposite of restrictive. It's completely, what's the opposite word of restrictive? It's completely allows them to do whatever they want, obviously, right? So that's the game here. They just make up new definitions as they please. I mean, can you see what's happening here? I mean, to me, I can see this. It's shocking. It's ridiculous. You know, it's obviously mocking me, and it's mocking the whole idea of a scientific debate. So this relates to Socrates' quote, I would only ask you to be consistent, or if you must change openly and there let there be no deception. Well, when you can make up new definitions and interpretations on a whim, mid-debate, then of course you can win any argument, right? So of course, this isn't argument, it's only sophistry and rhetoric, which the Greeks were quite familiar with as well, formally. Of course, one may change openly, but the changes themselves are the deception. Okay, yeah, so they're changing the definitions openly, but that's the deception, because in thermodynamics, the definitions are one thing only, and you can't just arbitrarily change the definitions and equations of thermodynamics with no references, with no mathematics to demonstrate how it works. I mean, it's just so ridiculous. So, of course, this is sophistry. Sophistry is such a great word. I love this word. It is defined as a method of argument that is seemingly plausible, though actually invalid and misleading, the art of using such arguments, but subtle but unsound or fallacious reasoning. That's such a great word. Okay, so that's obviously what's happening here. Previously, I mean, this sounds like a good argument. If you were to just think that physics works by words, then you would think, okay, well here, this is how they're defining heat, so why can't it work like this? Because look, here's a word definition, and that's how science works, right? That's how physics works, is we just have word definitions for things. Well, Joe, they're saying that your definition is too restrictive, and they're going to use a new definition for heat. And so now this is how heat is going to work, because they have a new word definition. And look, it seems consistent. The sentences are readable. They make sense, right? But of course, this goes back to Gödel's incompleteness theorem. You can make sentences which you can read. They have a good syntax. The sentence structure is valid. You can read it. Yeah, but are they saying anything semantically valid at all? No, they're not. They're just making up something entirely new and meaningless and sophistical. Okay? Physics does not work by simply coming up with word definitions and, hey, I have a new word definition for something. And that's how we're going to do the physics now. That's what climate science is doing. And this is what the people who defend climate science and climate alarmism and its greenhouse effect do. That's what they do for a living, is this type of sophistry. So we define heat as thermal radiation, which can come from an ice cube. Well, okay, well, that's what a nice new definition. So that's how physics works now. No, physics does not work like that. Physics is mathematics, okay? And especially physical laws in physics, like the laws of thermodynamics, are mathematics. The law of gravitation is mathematics. Kepler's laws of planetary motion are mathematics. Anything in physics that's a law, it's math, not words. The only reason you hear about it in words is because that's how we communicate, because most people are mathematically not illiterate, basically, right? If we actually had a society where everybody was completely mathematically literate, we would not actually communicate the laws of physics with words. Isn't that interesting? Think of a society where everybody was 100% mathematically literate instead of illiterate. We would never hear the law of conservation of energy, or the first law of thermodynamics, being communicated with words. We would hear it being communicated with a mathematical equation, okay? Because that's actually what physics is, okay? It's not word definitions that you can just make up as you please. It's mathematical definitions, which are fixed and immutable, okay? So finally, guys, don't forget about all this. Why is there sophistry in climate science? Why is there so much sophistry there? Because it's all based in flat earth theory. Because this is the foundation of climate science. It's flat earth theory. What do you call a flat line representing the entire earth? You call that a flat earth. That's not just a small, tiny little baseball postcard-sized portion of earth. This is meant to represent in climate science the entire earth. And look at this value. Divide by 4. They think that's a normal thing to do. They think that the solar input to the climate, because the earth is flat, that the solar input, therefore, by mathematical consequence, is 1/4 of its solar power. So the sun is 1/4 of its solar power on a flat earth, and that's how we understand the climate in climate science. Yeah. The earth is flat, and solar power is 1/4 of its power. That's how we understand the climate. Great. Solar power, which, and then that value, obviously, the 1/4 solar power, that's minus 18 degrees Celsius. So sunlight is minus 18 degrees Celsius. It's freezing cold, can't melt ice, doesn't create the climate. What creates the climate is the cold atmosphere making the surface even hotter and creating the climate within itself, because cold can transfer heat from itself to something hotter. Heat flow can reverse, because we're just going to use words to redefine thermodynamics, and we're not going to use math anymore. We're just going to use new word definitions for things that we make up on the spot to justify this flat earth theory. Okay, so it's all flat earth theory. That's why all the sophistry comes in. That's why they have to violate thermodynamics. Okay, all right, great. I hope you enjoyed that. That was, yes, another lesson. I mean, sorry to have that wall of text on that one page, but basically that's what we're going to have to do, is treat this like a classroom, like as if you're taking notes. And I hope that you will remember that and will put that in your repertoire of knowledge and use it going forward to not believe in flat earth climate science and climate change, climate alarmism. And it really tells you that you should really probably start distrusting everything that the whole expert class, media, academic establishment is telling you that you should do with yourself, right? Because if they believe in flat earth theory and they have no idea why that's wrong, can you really trust them to be doing anything else correctly? Really? Especially when there's so much money involved, right, guys, and control and political control. I mean, I'm an astronomer. I'm a classic scientist. I have no political conflict of interest or financial conflict of interest. I do astronomy because I think that space is grand and beautiful and amazing, and the galaxies and the solar systems and the Milky Way and all that is just mind-bogglingly beautiful and profound and large, and it just gives you a sense of scale that makes your mind escape itself, like that quote from Plato, "For everyone must see that astronomy compels the soul to look upwards and leads us from this world to another," right? God, you have this beautiful world up there. And then you have these goddamn psychos. These fucking psychos. God, this world could be so great. And it is great. What kind of psychopaths just say, oh, we're going to make up a new definition. We're just going to make up a new definition which has no mathematical basis or basis in science or thermodynamics, and we're just going to go with that. Yeah, I can't explain it. It's just psychotic. It can be explained in terms of power, influence, master and slave dialectic, perhaps. Yeah, I don't know. But it sure is insane. It sure is a joke. It sure does make this place into a clown world instead of a beautiful, amazing world of power and uh, and strength and virtue and merit. It sure just makes it a whole ridiculous place, doesn't it? Like comedically ridiculous. Our smartest people are flat earth theorists. And you show it to their face and they're just like, they're so brain dead. They're just no clue. They're robots. I swear they're robots. I swear that they're just somehow on a spiritual reincarnational level, the gods have like developed artificial intelligences that can be installed into zygotes instead of real souls. Maybe there's not enough real souls to go around for the huge population explosion that humanity has went under in the last, 40 years really only? 50 years? We've just rapidly ramped up to 8 billion people. Maybe there wasn't enough souls to go around to put real souls, real thinking minds, which follow the positive dialectic to increasing reason, pursuing ultimately the eventual gnosis that which we all want to find and reach in godhood, in merging with the one mind, you know, which requires reason, which requires, the positive dialectic, becoming smarter. So anyway, there wasn't enough souls to go around. So all the bodies being created just had to be installed, have AIs installed, artificial intelligence, robot kind of AI minds installed. And they just, because they're not real, because they're artificial, they don't follow the positive dialectic. They follow the negative dialectic instead. Instead of being drawn toward the light, they're drawn toward the darkness automatically because they're not real souls. They're robots. They're robots in human bodies, and because they're robots, they automatically seek the opposite of the light. They seek the opposite of the positive Hegelian dialectic of becoming and merit and truth. They go the opposite direction to absolute mediocrity and stupidity and retardation, creating a society full of the last man. Anyway, this thermodynamics class is going crazy, and the teacher even almost cried for a second. My gosh. All right, guys. Hope you're having a good day, a good autumn. It's beautiful here. I'm really enjoying myself. All right, guys. Take care. Bye-bye.